Welcome to another Win-Win Math video. Today's video will be solving triangles with the law of sines. I will also be giving you tips on the law of sines as well as some practice problems. So let's get to it. So for the law of sines, we know that sine of A over A is equal to sine of B over B is equal to sine of C over C. Let's focus on the first two ratios with A's and B's. So let's draw a triangle with those A's and B's. And let's suppose we want to solve for angle A. Then, if we look at the first two ratio, we need side A, side B, and angle B. Notice that we have all of the B's. If we have all the B's and one of the A's, then we can solve for angle A. Likewise, if we have all the C's and side A, then we can solve for angle A. Alright? Now, the highlighted blue part from geometry is known as side-side angle, or angle side-side. And from geometry, this is not a triangle congruence theorem. So there will be 0, 1, or 2 triangles. Then we have another variation of the law of sines, which is the reciprocal. We have A over sine of A equals B over sine of B equals C over sine of C. Now here we will be using this to solve for side A. It's easier to solve for a variable if it's in the numerator as opposed to it being in the denominator. And from this, we need these three information. We need angle A, angle B, and side B. Notice we have all the B's. You can do the same thing if you have angle C and side C and angle A. As long as you have one complete ratio of something, either all A's, all B's, or all C's. Now, from the highlighted blue part, from geometry, this is angle, angle, side, or side, angle, angle. And this is a triangle congruence theorem, meaning that there should only be one triangle. Now, so some tips for both of these variations. First tip, for sine of A over A, use this to solve for an angle. And when you use this, well, we got to consider there will be 0, 1, or 2 triangles. And for the second tip, if you have A over sine of A equals B over sine of B equals C over sine of C, use this to solve for a side. And for this, there should only be one triangle. For our first problem, we're given measure angle B, measure angle C, and side length C. Notice that we have all of the C's, so we're definitely going to be using that for our ratio. And since we have angle B, we're going to solve for side B first. Alright, so let's start off by drawing our triangle with the given information. So we look at this and we notice we have a side angle angle, or angle angle side. So this should only give us one triangle. Since we have two angles already, we can solve for the third angle. Since we know that all three angles add to 180 degrees, we can write that down. And then subtract measure angle B and subtract measure angle C to both sides. And then simplify, we get measure angle A to be 30 degrees. And then we'll write it down. So a tip for this problem is that we'll be solving for 3 different variables. So it's good, like once you solve one problem, to section it off. That way it doesn't get mixed up with others. Next, we have a choice up to you if you want to solve for side A first or side B. So I'm going to solve for side B first. Since we're solving for a side, we're going to use B over sine of B equals C over sine of C. Let's get B by itself. Multiply both sides by sine of B. We get B equals C sine of B over sine of C. We'll substitute the information that we have already. And then type it in the calculator. We get B to be about 20.5212 feet. So we'll put it to our table. Then since we're finished this variable, let's section it off, and we solve for side A. So it will be A over sine of A equals C over sine of C. Solve for A, we'll multiply both sides by sine of A, substitute the values in, type this the way it is in the calculator, and you get A to be about 15.9627 feet. Now, this graphic organizer will be helpful this on the top right, because you'll notice all 3 angles should add to 180 degrees, and not only that, the smallest angle should correspond to the shortest side. The next smallest angle should correspond to the next smallest side. And the largest angle should correspond to the longest side. So as long as this follows both of them, all 3 angles add to 180 degrees, small with small, large with large, then we know you're doing the problem correctly. So this is an example of a side angle angle with only one triangle. For our next problem, we're given angle A, angle B and side C. So looking at this, we're most likely going to solve for angle C first. All right, so let's draw our triangle. With the given information, we look at this, we notice we have a angle side angle, which should only give us one triangle. All right, so unlike the first problem, let's solve the second problem a little bit more faster and get rid of some needless work. So we can solve for angle C. We know that all three angles should add to 180 degrees. So 180 minus 43 minus 98 should give us 39 degrees. Next, let's solve for side length B or side length A. We'll solve for side length A. So we have A over sine of A equals C over sine of C. Multiply by sine of A both sides. So we have A equals C sine of A over sine of C. Substitute the values in, type in the calculator, you get A to be about 23.8415 feet. Since we found this variable, let's section this off, and then let's solve for side B. So we have B over sine of B equals C over sine of C. Multiply both sides by sine of B, substitute our values in, type in the calculator, we get B to be about 34.6181 feet. Now let's check our work. All three angles add up to 180 degrees. The smallest angle should correspond to the shortest side. The next smallest angle should correspond to the next smallest side. And the largest angle should correspond to the longest side. So this is an example of an angle side angle that should only give us one triangle. For our third problem, we have angle A, and side C. Notice that we have all of the A's, so we'll be using that in our ratio. Since this is our third problem, let's see where we can start introducing some more tips to make the problem much more easier. So let's draw our triangle with our given information. We'll notice that this is a side-side angle. So there's a chance that there's a second triangle with this problem. However, if we look at measuring angle A, we notice it's 110 degrees, which is an obtuse angle. If measuring angle A is 110 degrees, then measuring angle B plus measuring angle C should be 70 degrees. Therefore, measuring angle C must be less than 70 degrees, or measuring angle C must be an acute angle. So if we're given this option, then we should only have one triangle. So let's solve it. So let's solve for angle C. So we're going to use sine of C over C equals sine of A over A. Multiply both sides by C, we get sine of C equals C sine of A over A. To get angle C by itself, we're going to take the sine inverse to both sides. So we have C equals sine inverse of C times sine of A over A. We'll substitute all of our values in, and we type this the way it is on the calculator. Don't try to simplify it, type it the way it is on a calculator. And you get angle C to be about 48.7426 degrees. Now here's a tip about this. This portion right here, we want to store that onto the calculator so that we don't have to retype that every single time. Okay? Next, let's solve for angle B. We know that all three angles should add up to 180 degrees. And so if we subtract off measuring angle A and measuring angle C to both sides, we have measuring angle B equals 180 minus measuring angle A minus measuring angle C. Now, from that earlier tip, since we store C onto the calculator, we're going to use that stored value, and then we're going to store that new value, 180 degrees minus angle A minus angle C, and store it into angle B. And we'll get that to be about 21.2574 degrees. All right, we'll put that in, and since we've solved for this variable, let's section it off. Now we just need to solve for side B. Since we're solving for a side, let's use B over sine of B is equal to A over sine of A. Multiply both sides by sine of B, you get B equals A sine of B divided by sine of A. And then since we already store angle B and angle C in, we just need to use our angle A and side A into this problem, and we get B to be about 48.2284 centimeters. And that's our solution. If you are trying this on your own, you might get B to be about 48.2283 centimeters, which is off by 0.0001. The reason for this is that the first one, the 48.2284, you will get this answer if you actually use the stored value of B, meaning you're using the exact value all the way through until the very, very end. Whereas if you have B to be about 48.2283, it's because you're probably using B to be 21.2574. You're using a rounded answer. When you use a rounded answer, your answer is going to be rounded. Where if you're going to use the exact answer, your answer is going to be more likely exact, and then you round it later. So this is an example of a side-side angle with only one triangle. And almost forgot, do make sure check all three angles should add to 180 degrees. And smallest angle should correspond to the shortest side, the middle with the middle, and the largest angle should correspond to the largest side, the longest side. Here's our fourth problem. We're given angle A, and side B. Notice we have all the A's. If you want to try solving this problem on your own, pause the video and then we watch. And then also make sure to see, does the problem make sense to you? Okay? Alright, so let's solve. So we'll draw the triangle. With our given information, this will be a side-side angle, meaning there could be one or two triangles, or maybe even zero. Since we have all the A's, we're going to use that. And since we have side B, we're going to solve for angle B first. So we have sine of B over B equals sine of A over A. We'll multiply both sides by B, and we'll take the inverse. So we have B equals sine inverse of B sine of A over A. We'll substitute all of our values in, and then when you type in the calculator, you might notice you get an error on the calculator, particularly a domain error. Something's wrong with the domain. So you're probably saying that this triangle does not exist, which is our answer. This triangle actually do not exist. So let's look at why is there an error. Well, let's look back at sine of B equals B sine of A over A. If we type in B sine of A over A with those values in, we get sine of B to be about 1.6603. Sine of B is 1.6603. Well, sine of B is always going to be between -1 and 1. And since we get 1.6603, which is greater than 1, then there is no real number for measuring angle B. Therefore, there should be no such triangle. Sometimes we're given information that just does not make sense. It's up to you to interpret it. For our fifth problem, we have angle B, side B, and side A. Here we have all the B's, so we'll use that in our ratio. And we're most likely going to solve for angle A first. This is going to be an example of a side-side angle. Well, since we've been drawing our triangle, it does help us visualize this. Let's solve this without drawing a triangle. So let's solve for angle A. So we're going to use sine of A over A is equal to sine of B over B. Multiply both sides by A, and we get sine of A equals A sine of B over B. Since this is a side-side angle, there's a chance that there is a second triangle. So let's solve this as if it was just one triangle first off, which is we're going to take the sine inverse of both sides. So we have A equals to sine inverse of A sine of B over B. Substitute our values in. Type this the way it is on a calculator. We get A to be 44.9272 degrees. Next, since we finished this variable, let's section it off. Oh, and don't forget to store it in A. We'll section it off, and then let's solve for angle C. All three angles should add to 180 degrees. Use the stored values, and you get angle C to be about 108.0728 degrees. And then store this value on the calculator. Then let's section this off, and now we need to solve for side C. So C over sine of C equals B over sine of B. Multiply both sides by sine of C, and then substitute the values from the calculator. You get C to be about 37.6923 feet. Let's check. Does all three angles add up to 180 degrees? Yes. Does the smallest angle correspond to the shortest side, the middle with the middle, and the largest angle with the longest side? Check. So this is going to be one of our triangles. So how do we solve for our second triangle? So this first triangle, this all corresponds to the very first step, or solving for the first variable, which was A. And this is where we're talking about angle A is an acute angle. So for the first triangle, this is where the angle A is acute. The second triangle is where we're going to have angle A to be obtuse angle. So let's solve this. It's going to be very, very similar to what we just did with where angle A is acute. So angle A is obtuse. To do that, we'll do A equals 180 degrees minus sine inverse of A sine of B over B. Substitute the values in, type this in the calculator, we get 135.0728 degrees. And then make sure you store that onto the calculator. So here you notice I'm using all subscript 1 to signify the triangle with the angle A is acute, and all the subscript 2 is a triangle where angle A is obtuse. Alright, now solve for angle C. All three angles should add to 180 degrees. Substitute the values in the calculator, we get 17.9272 degrees. Store that in the calculator. And for side C, we'll do C over sine of C equals B over sine of B. Multiply both sides by sine of C, and type in the calculator, you get C to about 12.2041 feet. And then we'll check again, do all three angles add up to 180 degrees. Does the smallest angle correspond to the shortest side, middle with middle, and largest angle with the longest side. So they all check off. And this is how we're going to solve for two triangles for the side-side angle case. Is the very first step of angle A being an acute angle versus angle A is an obtuse angle. Notice if you look side by side, the process for both problems to solve for angle C and side C are pretty much exactly the same. You just have different variables. Just don't mix up your A's and C's between subscript A sub 1, C sub 1 versus A sub 2, C sub 2. Here's problem 6, another side-side angle case. Here we're given both A's and side C. So we're going to solve for angle C first. So we can have a triangle with angle C to be an acute angle and a triangle with angle C to be an obtuse angle. Pause the video if you want to solve this on your own. Alright, so let's solve the acute triangle first. So we have sine of C over C equals to sine of A over A. Multiply both sides by C, you get sine of C equals C sine of A over A. Now, let's assume that angle C is an acute angle. So, when angle C is an acute angle, then we have C is equal to sine inverse of C times sine of A over A. Type this in the calculator, and we get angle C to be about 8.9666 degrees. And then we'll section this off. Store it for C and section it off. Then let's solve for angle B. All three angles should have 180 degrees. Solve for this, and you get angle B to be about 139.0334 degrees. And then store it in for B. Next, section it off and solve for side B. So we have B over sine of B equals to A over sine of A. Multiply both sides by sine of B. Type this in the calculator, you get B about 21.0325 centimeters. Then let's check, do all three angles add to 180 degrees? Does the smallest angle, in this case C, correspond to the shortest side, C? Yes. Does the middle angle, angle A, correspond to the middle side, side A? Yes. And does the largest angle, B, correspond to the longest side, B? Yes. So it checks off, and this is how we solve for the triangle where angle C is acute. Now let's solve it where angle C is obtuse. So in this case, we're going to do C is equal to 180 degrees minus sine inverse of C sine of A over A. Type this in the calculator, you get C to be about 171.0334 degrees. And then we'll store it for C. You might notice if we were to solve for angle B now, if you solve it, you get angle B to be about negative 23.0334. Angle A and angle C already add up to be more than 180 degrees. Therefore, angle B must be a negative number. But for a triangle to have an angle that's a negative number does not make sense. So this is an example where this does not have a second triangle or does not have angle C to be obtuse. So this is an example of a side-side angle with only one triangle. Here's our seventh problem. we're given angle A, and side C. So we're going to solve for angle C first. So this is a side angle where there's a possibility of having a second triangle. So let's solve for angle C. Oh, also, pause the video if you want to try this problem on your own. Alright, so let's solve for angle C. So we have sine C over C equals to sine of A over A. Multiply both sides by C. And let's say that angle C is an acute angle. So C is equal to sine inverse of C sine of A over A. Substitute this values into the calculator, and we get C to be about 48.8959 degrees. And let's store that onto the calculator. Then let's section this off. Next, let's solve for angle B. All three angles should add to 180 degrees. Solve for angle B, and you got 84.1041 degrees. And again, store that onto the calculator. Then let's section this off. And finally, we solve for side B. So we have B over sine of B equals A over sine of A. Multiply both sides by sine of B. And type it in calculator, we get side B to be about 44.8831 miles. And then again, check. All three angles add to 180 degrees. Smallest angle, which is angle A, should correspond to the shortest side, side A. The middle angle, which is angle C, should correspond to the middle side, which is side C. And the largest angle, angle B, should correspond to the longest side, side B. So this checks off. Next, we need to solve for the second triangle, and that is where angle C is obtuse. So we have C equals 180 degrees minus sine inverse of C sine of A over A. Type this in calculator, you get C to be about 131.1041 degrees. And then we'll store it in the calculator. Then we'll do the same thing what we did for solving for angle B and side B when C was an acute angle. So all three angles should add to 180 degrees. Solve for angle B, you get B to be about 1.8959 degrees. And we'll store it in the calculator. And then solve for side B, we'll section this off. B over sine of B equals A over sine of A. Multiply both sides by sine of B, type it in the calculator, you get B to be about 1.4280 miles. And again, you can do a quick check. All three angles add to 180 degrees. Smallest with smallest, middle with middle, largest with largest. And we'll find out that this is a side angle with two triangles. And for our last problem, we have angle A, side A, we have all the A's, and side B. So we're going to solve for angle B first. So pause the video if you want to give this problem a try. Alright, so let's solve for angle B. Before doing that, we'll notice that angle A is an obtuse angle, which is 95 degrees. Therefore, angle B has to be acute. From this, we can already just cross this out. There should be no triangle where angle B is obtuse. So there should only be one triangle if it is a triangle. Alright, so solve for angle B. So we have sine of B over B equals sine of A over A. Multiply both sides by B. And then, since we know angle B must be acute, so B is equal to sine inverse of B sine of A over A. Type this in the calculator, you get 11.9783 degrees. And it will store it on the calculator. We'll section this off, and let's solve for angle C. All three angles should add 180 degrees. Type this in the calculator, you get about 73.0217 degrees. We'll section this, store for C, and then section it off. Lastly, we'll solve for side C. So we have C over sine of C equals to A over sine of A. Multiply both sides by sine of C, type this in the calculator, you get 7.0350 centimeters, about. And we'll check to make sure all three angles should add to 180 degrees. The smallest angle should correspond with the smallest side, middle with middle, and the largest with the longest. Alright, this is an example of a side angle with one triangle. And here's all you need to know of solving triangles with the law of sine. If this video helped, give it a like, subscribe for more, click on the video on screen to keep learning. Thank you.